In this video, we're going to have a look at enlargements. When enlarging a shape, it is important to know through which point you're enlarging. For example, we can enlarge this shape from the center outwards, or we can pin it on the left-hand side and enlarge from there. Because in mathematics we work on the system of axes, we are going to enlarge through the point 0, 0, or the origin. This means that the shape will be expanded or stretched out in all directions from the origin. So when we enlarge a shape, its vertices will move further away from the origin, and when we reduce a shape, it will move closer to the origin. So for example, if we want to enlarge this triangle by a scale factor of 2, we know that from the origin, in line with each of these vertices, we will move the triangle further away from the origin. Because the scale factor is 2, each coordinate will be doubled. So point A, which was at 2, 4, has now been doubled, and A prime is at 4, 8. The same goes for B and C. If, however, we want to enlarge by a scale factor of a half, in reality we are going to reduce, and the triangle will move closer to the origin because each coordinate will be multiplied by a half. For example, the coordinate A, which was at 2, 4, has been halved and now is at 1, 2. Here, for the first time, we can see that even though the original figure and its image has the same shape, it does not have the same size anymore. These three triangles are similar but not congruent because the one is an enlargement or reduction of the other. Example: in the sketch, triangle ABC is given. First question: triangle ABC is enlarged through the origin by a scale factor of 3. Draw the image triangle ABC prime. This scale factor implies that every single coordinate of the triangle will now be enlarged or multiplied by 3. So point A, which is at 1, 1, will be multiplied by 3, and A prime will be at 3, 3. Point B is 4, 1, and if we multiply this by 3, B prime will be at 12, 3. And lastly, we have point C, which is at 4, 3, so C prime will be at 12, 9. So the new triangle will be positioned here. Question 2. If C double prime, which is 8, 6, is a vertex of the triangle that is formed when triangle ABC is enlarged, what is the scale factor that triangle ABC is enlarged with? We already know that point C is the coordinate 4, 3. This will now change to a new coordinate 8, 6. Both the x and y value have been multiplied by 2, and that means the scale factor is 2. Question 3. Calculate the area of triangle ABC and of triangle ABC prime. If we start with the smaller blue triangle ABC, we know that the area of a triangle is a half times base times perpendicular height. The base of the blue triangle is from A to B, and that is 3 units. Then we have a perpendicular height from B to C, and that is 2. That means the area is a half times 3 times 2, which will give us 3 units squared. For the bigger purple triangle, the base is from A prime to B prime, and that is from 3 to 12, which will give us a length of 9. The perpendicular height is from B prime up to C prime, and that is from 3 to 9, which will give us 6 units. So this area is a half times 9 times 6, which gives us 27 units squared. Question 4. Calculate the ratio of the area of triangle ABC on that of triangle ABC prime. We've already calculated both these areas and know that this is 3 over 27, which can be simplified to 1 over 9. This 9 comes from the scale factor of 3, but because this is an area which is units squared, 3 squared will give us an area that is 9 times bigger.